Hi everyone, so welcome to the last day of our algebra review camp, okay? All right, so yesterday we talked about the system of linear equations, and then we focus on the first method we can use to solve this linear system by using the substitution, right? So today we'll be learning something different. So here we'll talk about another way to solve the linear system. And after you learn these two methods, you can just choose whatever you want to use based on the equations you have, okay? So the second way to solve a linear equation is by using linear combinations, okay? But again, what does that mean, okay? So let me first introduce to you like what does that mean for say a linear transformation, okay? So for linear transformation, suppose we have a x plus y equals to 1, okay? Suppose we have this equation right here. And then is there any transformation we can do? So of course, based on the properties of an equation, we can add the same number on both sides, or we can say subtract a number on both sides, right? Or we can also try to multiply or divide the same number on both sides. So here, the latter two will be called the linear transformation, okay? So for example, we can multiply the both sides by the number 2, so that we have a 2x plus 2y equals to 2, okay? So we see that these two equations are essentially the same equation because you can just divide it to the second equation here, and then that will give you the first equation, okay? So that's why we call this the linear transformation, because essentially these two are still the same equations, right? And then why do we need to do a transformation like this? That is because in a linear system, we can actually reduce the number of variables we have in this system by using the linear combinations, okay? So let's see what we can do. So let me just give you an example, okay? So suppose I have a x plus y equals to 1, and we have a, say, 2x plus 3y equals to 2. Okay, so I just made up a linear system, and let's see how we can use the linear combination to solve this one. Okay, so the first one, we have to choose the variable we want to eliminate, okay? So here we can choose either the x or the y, and let me just choose the x. Okay, so in order to eliminate the choice x, the variable x, I see that I have to cancel out the x. Okay, so to cancel out the x, I first notice that okay, the coefficient for the x in the other equation is 2. So I need to make the coefficient for the first equation to be the opposite of the equation, the coefficient. Okay, so here the first one is a negative 2x minus 2y equals to negative 2. Okay, so the first step, I want to multiply a negative 2 on both sides for the first equation. And then for the second equation, we don't have to do anything. So just leave that as a 2x plus 3y equals to 2. Okay, and then what should we do? So we see that now we have two sets of the equations. And then for one of these variables, the coefficients are opposite to each other. So we can actually just add both sides of these two equations, right? Because imagine if you have a equals to b and c equals to d, right? So imagine if you have a equals to b, c equals to d, then of course you also have a plus c equals to b plus d, right? We still have these equations. So it's the same idea. So here we can also try to add the left-hand sides together, and that will equal to the sum of the right-hand side. So here, the left-hand side is a negative 2x minus 2y, and then plus a 2x plus 3y. Okay, so that will be the sum of the left-hand side. And then for the right-hand side, since we just have a negative 2 and the 2 here, so the sum equals to 0. Okay, and then simplify the left-hand side. We see that the 2x is actually canceled out. So we have the 2x and 2x got canceled out. And then we have the 3y minus 2y, which equals to just a y. Okay, so for this particular equation, we see that we can also reduce the number of variables we have using a linear combination. So here, solve that, we have the y equals to 0. And of course, after you got one of the solution, then just plug in into either of these equation, and then you can figure out the x. Okay, so for this one, if you plug in the y equals to 0, you should be able to have the x is equal to 1. Okay, so that is the whole idea of using linear combination to solve the linear system, right? So basically, if you want to like say add these two equations, and before you add, make sure you first multiply that so that you have some opposite terms. Okay, so that's the basic idea. And then also give all of these questions a try and see if you can understand these concepts. Okay, And that's it for the whole algebra review camp. So I hope everyone has at least built some foundations on the algebra, because we know that algebra is really important for middle school class, right? We have pre-algebra, we have algebra 1, and we also have algebra 2. So all of these contents are based on these foundations, especially for like the calculation and the algebraic expressions. Okay, so I hope everyone is getting more comfortable with these ideas and in the future. So if you have any other questions like on these foundations, then I hope you can still remember this stuff. Okay. And by the way, we will also have some classes at Think Academy. So if you are interested on that, then stay tuned to our like the class outlines. And I hope to see everyone here at Think Academy. Okay. So bye. Thanks.